Have you ever think that palm oil industry in Malaysia produce abundant of solid biomass waste? What can biomass waste be used for? Does this solid biomass waste has a potential to be a renewable energy? Can we do something with it? By the way, my name is Nurul Alia binti Muhammad Azman. I am a final year student from Chemical Engineering Technology Department in UTHM. I found a solution to convert biomass waste into a valuable product by doing my bachelor degree project. I will transform palm kernel shell into biofuel briquettes to solve the problem. Thus, the title for my bachelor degree project is Production of Smokeless Biofuel Briquettes from Palm Kernel Shell Assisted with Slow Pyrolysis Treatment. This project was assisted by my supervisor, Dr. Nasra Fikri bin Chitpa. Thanks for his invaluable guidance and encouragement to make this research possible. Overall, the main objective in this laboratory experiment to determine the visibility of palm kernel shell by comparing combustion properties of briquette sample with commercialized wood charcoal. In this experiment, I'm using two different binding agents which are starch and sodium hydroxide together mixing with palm kernel shell biochar. Slow pyrolysis was conducted in a furnace at temperature 200, 400 and 600. Results from this study found that briquette sample treated with pyrolyzed temperature of 600 degrees Celsius together mixed with 5% starch is the most suitable alternative to charcoal. For your information, during 2015, Malaysia produced 75.61 million tons per year of solid biomass waste in palm oil industry. In relation to waste management and greenhouse gas production from solid biomass, the increase in waste generation raises environmental sustainability challenges. Therefore, biomass waste was converted to a valuable product which is biofuel briquettes. Thus, concept of waste to wealth has been implemented in this study. Palm kernel shell is highly lignocellulose biogenic waste by raw palm oil processing. In this figure, as you can see, PKS is the hard part containing palm kernel fruit but which contain palm kernel seed. There are also the solid biomass in such empty fruit bunch and mesogal fiber. Pyrolysis can be described such as in the equation in this figure where the initial biomass waste will be heated at a certain temperature and the initial pyrolysis product consists of solid char and condensing gas. More condensable gas will break into liquid. Non-condensable gases such as carbon monoxide, carbon dioxide and methane. Slow pyrolysis is described as the absence of oxygen where the biomass is slowly heated to relatively temperature approximately 400 degrees Celsius. The main advantages of briquetting therefore include producing high thermal efficient solid fuel, reduced waste volume, having a lower energy consumption for production, and environmental conservation. In this section, preparation of PKS briquettes including collecting of raw PKS and then drying for 4 days, grinding and sieving. Then, slow pyrolysis will occur at 200, 400 and 600 for 30 minutes and produce palm kernel shell biochar. Then PKSB will mix together with binding agent such as starch and sodium hydroxide at composition 5%, 10% and 50%. The briquette will compress manually by hand since we don't have briquetting machine in UTHM. Furthermore, the PKS sample and wood charcoal were characterized by its calorific value, porosity analysis such as volatile matter, ash content, moisture content, and fixed carbon by using thermal gravimetric analysis. Water boiling tank was conducted in order to determine specific fuel consumption and burning rate. Finally, the best PKS sample was selected and compared with wood charcoal. In this study found that high heating value or also known as calorific value, ash content and burning rate plays a significant role to determine the quality of biofuel briquettes. As you can see in the graph, high heating value versus different temperature and wood charcoal, sample of 600 degrees Celsius with 5% composition of starch show the nearest value to the wood charcoal which are 10.5 megajoule per kg and 12.03 megajoule per kg respectively. This energy value can produce enough heat required for households cooking and small-scale application. For graph ash content, sample 600 degrees Celsius with 5% starch show lowest ash content value compared with other including wood charcoal. Ash has a significant influence on the heat surface of a fuel as well as the diffusion of oxygen to the fuel surface during char combustion. As ash is the impurity that will not burn, fuels with low ash content are better suited for thermal utilization compared with high ash content. According to the Shaw et al. 2012, the higher the ash content, the lower its calorific value. In the graph of burning rate shows that the burning rate increases in the most samples as temperature increases. However, the burning rate values of the briquettes obtained decrease with increase binder proportion. In this study discovered that the binding agent of the PKS and sodium hydroxide prevented the fast burning of the briquette. Thus, in conclusion, palm kernel shell can be an alternative to charcoal. Besides, PKS sample of 600 degrees Celsius with 5% starch was chosen as the most suitable alternative since it has higher sweet carbon, low ash content, moisture content, and high calorific value. The concept of waste to wealth was successfully implemented in this study and also able to maintain environment sustainability. Hi, for those who are watching my presentation video, thank you and have a great day!